Hello students, welcome to the course Network Theory. In the previous video, we discussed the problems on Thevenin's theorem using basic finding of RTH. Okay, so today we'll see the remaining methods with problems on that. So just to recall, what was the action plan for solving any Thevenin's theorems problem is, so we have to identify the circuit A and circuit B, and you have to separate it, and then separated circuit A you have to find the Thevenin's equivalent circuit, and then you have to connect the circuit B and find the parameter of interest. Okay, so what is the catch here is, so how you find the RTH here? So there were three methods. Okay, so in the previous video we have seen one of the method by, if you have only independent sources, it may be current source or voltage source, just you will deactivate, and from the terminals AB you look at, from the seeing you will find out is it connected in series, parallel, or whatever combination, you will find the RTH. Okay, but now we are going to see the second method, so where the circuit will have now, along with independent sources and resistors, there is a dependent source. Okay, so it contains resistors, dependent and independent sources. So then you could not do follow the second step, remember this. Okay, so that's why Thevenin's theorem, whenever is asked, you have to look into the circuit first and identify the elements which category they fall. Okay, so in case they have along with independent sources a dependent source, then you follow this step to find out the VTH, RTH, and the final parameter. Okay, so first determine the open circuit voltage VOC with the sources activated. Okay, and this step is no changes. So whatever you have find out VTH, it becomes the VOC. Okay, so that's why this step is not new. So first part of the this one you are finding VTH, right? That is only acts as the first step here. Okay, second step is the new thing. What you do here is you will short circuit the terminals AB. So find the short circuit current ISC when a short circuit is applied to the terminals AB. That means we'll short the terminals AB. So previously what you used to do, when you deactivate the independent sources, there are only resistors are available. Now when you deactivate here, dependent source will present. That's why we will not follow that method. Instead what we'll do, along with independent sources, dependent sources, we'll short the terminals AB and we will mark a current ISC, and we'll try to find that ISC, and then we'll take the ratio VOC nothing but VTH divided by the this new ISC, we'll get the RTH. So then we'll draw the equivalent circuit of Thevenin's equivalent circuit, VTH in series with this RTH, and then the fourth step is same, connecting the circuit B and finding the parameter of interest. Okay, so we'll see an example here to understand this. So note down this problem. So find the Thevenin's equivalent for the circuit shown in figure with respect to terminals AB. So see here, this is a different variety. So here there is no load is connected. That means circuit B is not at all, it is present. So they have opened and they have given only circuit A. Okay, so note down this circuit. So you have a, just looking into the diagram, you have a dependent source here, minus plus 2I, and that I is dependent on the current in this 6 ohm resistor. Okay, and this is the 20 volt independent source, and along with 6 ohm and 10 ohm resistors are connected. So now what you have to do is, so your step is up to 3. So circuit A they only have given, just you need to find the Thevenin's equivalent circuit. That means you need to find the VTH, that is the open circuit voltage. Okay, so as you are doing in previous cases, apply the KVL, then the current across this will be the current, and resistor value will be the VOC. So next case is the new thing. So you have to short this terminal, okay, AB, and you need to find the RTH. Okay, so that part we will do. That is the thing. So hope you have noted down this question. Okay, so we'll try to solve this with the steps. So first to find VAB, VTH, VOC, nothing but all are same. Okay, so that voltage across the terminals AB, Thevenin's equivalent voltage, as well as the open circuit voltage, all words are same. So we'll apply KVL around the mesh. So normally when we find VTH, we'll have the KVL, and when we find the RTH, normally ISC, so normally KCL will come. Okay, so KVL is nothing but mesh analysis. Okay, KCL is nothing but node analysis. Okay, alternatively these names are used. So when you apply here, so you got this value. So how you got this? So KVL, KCL, you should not get problem. Okay, after coming so far. So you have minus plus. Okay. When I told you there are two conventions will follow, minus plus we'll consider it as plus 20, and we have taken this direction as current. So that's why current always enters the positive terminal in the resistor case. Okay, because it is absorbing element. So 6 ohm, then it is minus plus is there, and this is again plus minus. Okay, so that's why you have 20 minus 6 I, then this is minus plus, so that means plus 2I, and again minus 6I equal to 0. Okay, another way, if you write here minus sign is beginning, so you write minus 20 plus 6I minus 2I plus 6I. So both will give the same answer. Okay, any convention you follow, so don't confuse. Okay, so that's what written here. So now if we simplify, minus 6 minus 12 plus 2 minus 10i, so 20 minus 10i is equal to 0. So this, if you take right side, 10i is equal to 20. That step I have not written, straight away I value I have written, which is equal to 20 by 10 equal to 2 amps. So resistors are given in ohms here, that's why current is in amps. Clear? Since there is no circuit flowing in 10 ohm resistor, there is one more resistor was there, right, along with 6 ohm 10 ohm, right? So there is no current in this because it is not connected to any branch upper or right. So whereas previous problem we had, right, there is a current I2 or something, I1 was there, so we have considered, but now in this case it is not there, so that's why current is 0. Current is 0 means voltage is 0 in this. Okay, so that's why it is only depending on the current and resistor of this 6 ohm resistor. That's why VAB or VTH is equal to 6 into I. I value is found out 2. 6 into 2 is 12 volt. Okay, so this is the VTH value. You got the first part of the problem, VTH. So now we have to find the RTH here using our new method. So that's you have to be understanding. So this is nothing new, just the steps are new. So finding out the values, it is same as what you have done earlier. Okay, a short circuit is applied between the terminals AB. Then Thevenin's resistance is found out using the relation VOC by ISC. Okay, so VOC we are not finding, which is nothing but the VTH only. So now we will try to focus on ISC. So this is the short circuit current here. See here, ISC. Okay, so there are two loops are there. So we'll apply the KVL here, and we call this as I1 current now. So that's why this becomes now I1, and this also becomes I1 here. Okay, so note down this, I have not made changes. So you write the two equations and solve it, and this I2 current is nothing but the ISC. Okay, and this I1 current is nothing but the I. Okay, so even you can take this as I only, this you can take it as I only, this you can take it as straight away ISC. Okay, so there is no problem. Okay, so that's way also you can do, but when you are convenient with I1 I2, you can use that notation. Okay, no issues. So I have done here I1 I2 will solve. Okay, so applying KVL clockwise for mesh 1. So this is almost same as the previous one. Okay, only thing is this is the new one here. Okay, earlier it was open, now it is closed. That's why this is I1 minus I2 came for 6 ohm resistor. Okay, remaining all same. So 20 minus 6 I1 came now, plus 2 I1. I1 sorry, I is not I only written. Okay, this is not changed as it is I only, because I is now I1 minus I2. Okay, fine. So minus 6 I1 minus I2 is equal to 0. So don't change that in circuit. So this is now minus 6 I1 minus 6 I1 minus 12 I1. Okay, and then minus plus 6 I2. So this we have taken right side and rearranged the equation. So you got 12 I1 minus 6 I2, and left side you had as it is 20 plus 2I. These are the two sources, right? One is dependent, one is independent, that we have grouped. So now we have to substitute for I. What is I? Which is across 6 ohm now. Since circuit is closed, now it is not the straight away current I. It is a now I1 minus I2 current. So that's why we have to substitute there. So this is same 12 I1 minus 6 I2 same, and here I will substitute 2 I1 minus I2, and this will take it again left side to simplify I1 and I2. So 12 I1 minus 2 I1, it is 10 I1. Straight away I have written. Okay, hope you understand this. And minus 6 I2 and minus 2 I2 is there here, so it will become plus 2 I2. Okay, that's why minus 4 I2 equal to 20 as it is. So now the equation is clear. You got the first equation, right? Then applying KVL clockwise for mesh 2. Okay, so mesh 2, what and all you have? A 10 ohm resistor and 6 ohm resistor is there. What is the current in 10 ohm resistor? It is I2, only I2, right? So minus 10 I2. Okay, it is plus minus, and this is a I2 minus I1 now with respect to I2. So minus 6 I2 minus I1 equal to 0. If you simplify this, so you will get minus minus plus here, that's why plus 6 I1. Okay, so this is plus 6 I1 minus, so this is 10 I2 and this is minus 6 I2. So minus 16 I2 is equal to 0. Okay, so even if you know the manually also you can solve this. Okay, so 10 I1 because only two variables now. So just you can multiply this with 4, right? Multiply this with 4, you will get 4 into 4 16, and this equation you multiply with 1. Remember, no, solving in PU levels and all, you have done this. Okay, this is by 1 and this is by 4. Then you will get 40 I1 minus 16 I2 equal to 80. Here this is as it is, 6 I1 minus 16 I2 equal to 0. Then you subtract it. Okay, so if you change the sign, so if it is here plus minus, so here plus, and then so this will cancel out, you will get 16. So we have to do minus, right? So minus sign, so 4 I1 is equal to 80 will come, so I1 is equal to 20 ohm ampere, right? So that is a difficult, so you are not following, so better you go for calculator, go in complex mode equation, two unknowns. Okay, you select two unknowns and enter these values as A1 as 10, B1 as minus 4, and C1 as 20, and second unknown A2 is equal to plus 6, this plus 6. Okay, so and then B2 equal to minus 16 and C2 is equal to 0. Substitute this, it will give the answer. The first value will be I1 and second value will be I2. Okay, but we are interested only in second answer. I2 I will note down, which is the ISC current, so that will write. Okay, so solving the above two mesh equations, we get straight away I2 is written here. Okay, see here. So this is solved here, 120 by 136 amp, or it is, you can find out the if it is calculator, it will be giving some decimal points. Okay, even you can write like this. So from this now RTH is equal to VOC by ISC. So 12 by 120 by 136, so it is simplified, 136 by 120, 12 tens are, so it is got 13.6 ohm. Okay, so this is the RTH value. Okay, so now you have to write the final step. Thevenin's equivalent circuit is VTH in series with RTH. VTH value is 12 volt and RTH value is 13.6. Simple. Only thing is the step. Clear? The first step, deactivating the independent sources. Second, if independent source is present along with independent sources, then we have to follow this short circuiting the terminals AB, and you have to find the ISC current. Okay, VOC is same as VTH. So take the ratio, you'll get the RTH. Write the Thevenin's equivalent circuit. So if they can ask circuit B also here, find the next further cal. Okay, that is not asked in this problem. That's why. So this problem stops over here. Okay, this is the Thevenin's equivalent circuit. Clear? Okay, so you have to learn two steps now. We'll go for third step now. Okay, so what is the third step? There is no independent source at all in your circuit. Only dependent source and resistors are present in the circuit. Then what you will do? Okay, so that is the method I will recall. You have seen in first step. If the circuit contains resistors and only dependent sources, then what will happen? There is no generator energy source. That means open circuit voltage is 0, VTH is 0. So for that, what we'll do, we will connect a 1 amp current source to terminals AB and will determine the voltage VAB. Okay, so this is current and this is the voltage is measured, and that ratio VAB by 1, Ohm's law, V by I, right? I is 1 amp, so you'll get the RTH. Okay, or another method also you have, you can connect 1 volt voltage source and you can measure the current, okay, flowing from B to A. Okay, B to A current you find, so you will get again voltage by current. Voltage is 1 volt, current is IBA. If that ratio also you take, you'll get the RTH. Okay, so clarify this both steps. Okay, so one example 1 amp, another example 1 volt. So both I will consider two examples now having dependent source and resistors, and we'll try to show you how to take this ratio and write that. Okay, and remember, in the equivalent circuit in this case will be only resistors will be present. Okay, Even you can show the voltage source with 0 volt. Even you can show the VTH with 0 volt. This like this also you can write, but value is 0 volt, meaning what? It is short circuit, and that's why only resistor will be present in the Thevenin's equivalent circuit. Okay, remember this. Clear? We'll do that. Okay, so note down the first problem in this category. Find the Thevenin's equivalent circuit for the circuit shown in figure. Find the Thevenin's equivalent circuit for the circuit shown in figure. So note down. So there is a dependent voltage source, 5 ohm resistance and 10 ohm resistance. Okay, see here, there is no energy source here. Without energy source, what will be there? Okay, so it is VOC is 0. So VTH is 0 in this case. Fine. So what is the type of this voltage source? Dependent voltage source. It is a voltage source depends on current. That's why it is current controlled voltage source. Okay, so this is not required. Whatever classification it may be, we are not bothered about. Okay, so now VTH is 0. So what we will do is we will connect a 1 amp current source here and we will measure the VAB. Okay, so that will do, or else 1 volt current voltage source and we will measure the current IBA. Okay, so that step I will show you next. Okay, so hope you have noted down this question. Okay, so see the solution. Since the circuit has no independent sources, I equal to 0, then the terminals AB are open. Therefore, open circuit voltage or VTH is equal to 0. Okay, so this is important observation here. To find RTH here, the is now to find. Okay, so this word I don't know. Okay, TH. Now to find RTH, we choose to connect a source of 1 amp across the terminals AB as shown in figure. Okay, so this is the terminals was open now. So for that we have connected a 1 amp current source in upward direction. Okay, so you have to supply some energy and so that we can find out, right? And we'll find the voltage across these terminals AB. Okay, 1 amp current source is connected and we'll find out the voltage across this VAB, and that VAB by 1 will give you the resistance value. Okay, so how to find out this? Okay, so that we will see in the next. Note down this whatever I have explained. So we'll apply KCL at node A. Okay, fine. What is there? Sorry. Okay, so KCL. So all are at equal point. So I can apply the KCL here. So KCL means assumption is all the currents are leaving the node we will consider normally. Okay, all the currents are leaving. So there are 3 branches are there. So now, so you have one branch here. This is the reference node VA minus 0 by 10. Okay, VA minus 0 by 10. This is the first step. I have not written straight away. I have written because you are familiar. Plus, so this is VA in this branch. There is a voltage source here. So VA minus 2I. You write down this. Okay, it is not there in next step. VA minus 2I dependent divided by resistor value is 5, and there is a current coming here. That's why I will take it as minus. Okay, it is opposite to the what I have assumed. So that's why it is minus 1 equal to 0. So next case what I will do, I will group this VA term, VA by 10 plus VA by 5 equal to 1. I will take right side 1, and this minus 2I by 5 also I will take right side. It will become plus 2I by 5. That is written in the equation. Straight away I have written. Okay, so you noted down this no equation. Fine, pause it and note down. Okay, if it is removed. So 1 by 5 plus 1 by 10 we equal to 1 plus 2I by 5. So straight away I have written this. Okay, also what is I there? So I is flowing across the 10 ohm, right? So it is VA by 10. Okay, VA by 10 is the current I. So that we substitute here where I is there. So that's why 1 by 5 plus 1 by 10 VA equal to 1 plus 2 by 5 VA by 5. Okay, so VA by 10. So we'll this one cross 2 ones are 2 5s are, so VA by 25 you will get. So we'll take this left side. Okay, because VA is there, so that we can cancel out by taking LCM. So we'll group it 1 by 10 plus 1 by 10 VA minus 1 by 25 VA equal to 1. So we'll take LCM. LCM will take it as 50. So 5 tens are, so 10. Then 10 fives are, that's why 5. 25 twos are, that's why minus 2 VA equal to 1. So you'll get here 15 minus 2 is 13 by 50 VA equal to 1. So VA is 50 by 30 volt. Okay, so you can take the ratio also, you can keep as it is. Okay, so what is this? VA is nothing but VAB, right? So which is at the same. So that VA is nothing but the AB, right? So B is the grounded terminal, A is the upper terminal. So just we have taken VA there while calculating. That is nothing but the VAB. So VAB by 1 is nothing but 50 by 13 ohm. You can calculate this. So 13 threes are 39. 39, then we will have 11 remaining. So next 13 eights, I think. So it is 104, I think. Then how much it is remaining? 6. 13 fours are 52. Then again 8 is remaining. 13 sevens are, right? So like that you will get some 3 point something value. That also you can write or you can keep as it is. Okay, so this is the Thevenin equivalent circuit. You will ask, right? Thevenin equivalent circuits, there is an VTH should be. Okay, so VTH is there, you can draw this. Okay, you can draw the VTH, you can show plus or minus VTH equal to, what is the value of VTH here? 0 volt. Okay, like this also you can show, no problem. Okay, so this is a short circuit. Instead of that, you can connect a voltage source and you can show the value as 0 volt. Okay, so both are correct, no issues. Hope it is understood by connecting 1 amp current source. Similarly, we'll take another example now by connecting 1 volt voltage source, finding the resistance. Okay, note down the question. Determine the Thevenin's equivalent circuit for the circuit shown in figure. Circuit is very simple. So you have a current source here. This shows the current source 1 by 2 Vx and 4 ohm resistor, and Vx is nothing but the voltage across 4 ohm resistor. Okay, so what type of dependent source here is? It is a voltage controlled current source, VCCS. Okay, just to show you whatever we have learned in basic concepts of network, to understand that I am showing this which type of, okay, this is sometime required. Okay, fine. So it is a dependent source and resistor now. So we have to follow the second method. We'll connect a 1 volt voltage source and we'll find the current IBA. Okay, note down this question if you have completed. Okay, so pause it and note down if if somebody is missed out. Okay, as there are no independent sources in the circuit, we get VOC or VTH is equal to 0. This we know, right? Since it is coming, that's why we are connecting the source now. So to find RTH, so what we'll do now, connect a 1 volt source across the terminals AB and we'll measure the current I that flows from B to A. This is the step. Okay. So this is the circuit we had 1 by 2 Vx and 4 ohm, and this was the terminals open. I named it as VAB. Okay, there are no, it was not named AB, XY, any name you can give. AB I have named it, and now I have connected a voltage source with plus minus terminal, and current direction I have shown from B to A. So this current I need to find, and this current by 1 volt will give you the ratio RTH. Okay, so again we'll apply the KCL here. Okay, so VA. Okay, so that only will apply. Fine. So what you have here is, we'll assume that in the node analysis, currents are leaving the branch, right? So accordingly, we will consider. So what you have here is a current source leaving the node. That's why it is plus Vx, right? So it is 1 by 2 Vx. Even you can take this Va or Vx. Okay. How I have taken, I will see there. Okay. Va or Vx, anything. Then this is plus, so this side. Okay, so you have Va by 4 or Vx by 4. Vx by 4, so this branch, and now this branch, so you have Vx minus, this is plus minus 1 volt is connected, no, that's why Vx minus, sorry, so here no resistors are connected, so we call it as just current entering the node, that's why minus I equal to 0. Okay, so this will take minus I equal to 0. and we'll solve this. Okay, Vx will substitute like that and we'll solve it. Okay, note down this much. Okay, applying KCL at node A, I have considered Vx only. Okay, so 1 by 2 Vx, I have named it as 0.5 Vx. Okay, I have rearranged it. So the same equation you can write 0.5 Vx, what you had there, or 1 by 2 Vx, then Vx by 4. Okay, current entering minus 5 is equal to 0. So now what I have made, I have grouped this, right? So because I know the value, so I will just take I right side. Okay, so I will take just I right side and rearrange. So I is equal to, so you write like this. Okay, if I equal to 0.5 Vx plus Vx by 4, 0.5 Vx plus Vx by 4. Okay, so it is already known to you. What is this value? 1 by 4 plus this one. It is 3 by 4 Vx or 0.75 Vx. Just you have to substitute now value of Vx. So what is Vx value there? It is 1 volt, right? We have connected 1 volt across Vx, right? That's why its value is 1 volt. So just if you substitute that, what you will get? 0.75 amps. Okay, 0.75 into 1, it is 0.75 amps. So this is the current IBA. Okay, so we need to specify this current IBA. So everywhere use that notation IBA. Okay, even in the circuit you show it as IBA. Okay, so now we will take the ratio 1 by IBA. Okay, so hence RTH is equal to 1 by 0.75, which is nothing but 4 by 3 equal to over 1.33333 ohm. Okay, so this is the Thevenin equivalent circuit now. So having VTH and RTH. So RTH is only shown, VTH is also there, man. So you could not omit that. Okay, so you can show like this: VTH is equal to 0 volt. You have to write. If you write like this also correct, or if you just short circuit it and just show the RTH equal to 1.33 ohm, also correct. Okay, so hope it is clear. So the both methods I try to show you with the example programs which is asked in exams only. Okay, fine. So with this we'll end the session for today. Okay, in the next video we'll see some of the AC elements. Okay, so J terms, okay, complex term we'll see and try to solve two problems using Thevenin's theorem. With that we'll end the Thevenin's theorem also. Okay, thank you. We'll meet in the next video.